So I'm Jennifer Montano. I represent the enterprise geospatial side of Google, and I manage the United States with people who represent the different areas underneath me. And so I have an 18-year experience with GIS. Started when it was command line with ESRI. So a long time coming to get to where we are today, which is past creation to visualization, okay? That seems trivial in your mind, but it's not. It's a long time history to get to where we are today. So I put the title of my slides, Breaking Down Silos for Transparency of Information. Everywhere I go, I talk about empowering transparency, because that seems to be the resonating theme. You use democratization. We use that a lot, too. So key, powerful words when we go through this presentation. If I had to boil it down to 3 words, what I do every day, it's aggregate. I'm helping our clients to aggregate their information, whether it's in the cloud, whether it's on their own servers, whether they're sharing with their own agencies, whether they're sharing it to the public, it's aggregation. The second is collaborate. How can I better collaborate interagency with my public, with my peers, so they have the same understanding as me? And then lastly, it's enable. If I had to ask you today, what's your biggest challenge? It'd be enabling field operations, would it not be? So that's the 3 words I want you to remember when you leave today. So no big surprise there. Huge amounts of data in the world, right? Look at all the millions of tweets and the millions of assets out there and the millions of workers, the billions of assets and billions of workers. So what's the challenge? How do we organize that and make it more meaningful when we present that information? So would you expect that Google would be part of this, that would be part of our DNA to handle these large scenarios? Yeah. We're handling 20 billion pages per day, 100 billion queries a month, 425 million Gmail users, 72 hours of video uploaded per minute. We have 200 petabytes of imagery on our data servers. We're meant to scale. We're meant to supplement your environment so you're safe, you're secure, your data is always up. So going back to the theme of removing silos of information, imagine that you've got these data sets that are all disparate, right? I grew up in GIS when it was like, here's a data set, here's a data set, there's a data set, right? Well, imagine today that you could have this search appliance from Google, searching for those keywords that you need at all times, whether it be crime related, whether it be weather or incident related. It's crawling all the time. And then the backside, you could visualize, where is that on the map? What trends could I see? We're working with a lot of law enforcement to say, how do I tie these things together so I'm more effective when I do my job? And Dave will actually show you the end user map of that. So we talk about a common operating picture. It's kind of an overused word, right? But you want to make that affordable. A common operating picture can take time and money. We're here to help you do that, whether it be our on-prem or cloud-based solutions. Here you're seeing Virtual Alabama. I'm sure you guys have seen it. I've done a webinar with them where they took a disaster and took multiple layers of information across the state, because that tornado went across multiple counties, and said, where was the disaster, who owns the property, and so happens there was a school in that. So who was in the school? Where is my infrastructure in that school? And now they have a whole big initiative on safe schools. They've mapped out 1,600 schools. They know where any measure of students are during the day. They know where the infrastructure is if they need to cut it off. And they've got cameras in real time. So they can turn it on at any time and say what's going on in that classroom. So as far as creating your self-situational awareness, you have to kind of blend in with or connect to traditional systems like computer-aided dispatch. Here's a screenshot from Washington, D.C. We're seeing the crime mapped in real time as it's coming into that CAD system. So we have to be flexible as a provider that says, I can take in all types of environments. So I'm working closely with a partner called Edge 360. They do camera integration. We're working with the Atlanta Police, Miami-Dade Police, and many others to say, These camera systems are legacy. You can't integrate them very easily. So they're taking that job on, and so they've integrated their cameras and search and geo into those environments. It's a pretty powerful situation. And if you remember, there was a shooting in Atlanta, and this really raised this project up. Dave's going to show you how we help emergency resources in the field. We enable them with the situation that you're seeing on your desktop. You're seeing where you need to go. How do I report back information from the field? Am I safe? And you can do this in real time in the cloud and disconnected. Here's an application where we built to enable field officers. They want to know if I'm going to an address to deliver a warrant. What do I know about that person? What else can I do in the area that may be of importance to do? What does that area look like? So you incorporate things like Street View, so I can see the 360 view of where I'm going. We also partner with people like predictive policing that says crime mapping is not just, crime analytics is not just crime mapping. It's about understanding where do I need to be at this time of day for that type of crime, okay? So it's a little bit of more unique understanding. We talk about it all the time. You want to empower your citizens. So how do you do that? Allowing them to have a website to go to is pretty basic, right? But you want to enable them with things like mobile applications. My Mobile Witness is based on Google Maps. I can report a crime at that point and say, here is something I saw, here's a picture, whatever I needed to do to report that crime. So what powers this? And so I won't go through this long because I want Dave to go ahead and present his side. But when you talk about building a solution to empower transparency, you have to have familiarity. Okay, what's that mean for us? 1 billion downloads of Google Earth. 1 million sites use our maps technology. 200 plus petabytes of imagery, like I mentioned. And we can handle these multiple queries per second if you ever had that scenario. Our servers are not going to go down. So what is it? We operate in the way that which you like to operate. Like Manoj said, we're not all cloud. But we do have some pure play cloud solutions like Maps Engine. Load your data in, create maps without coding, and share it with who you want to share it with. Maps API, everybody knows it, you've seen it, you did it when you went to a restaurant. It's finding that information in the easiest way that you can, however you can. We've got on-premise-based solutions, and we've got field force solutions called Google Coordinate. So Dave, I'm going to call you up here. So while Dave is getting set up, he's going to walk you through some of the capabilities that I spoke to, but give you that visual, impact of what does that mean? What is it? What can it do?
Okay, great. Can you hear me? Thanks. All right, so my name is David Makovsky. I'm a geospatial solutions engineer here in the New York office. So I'm happy to be your local point of contact for any technical mapping questions you might have. I want to show you a few examples today of how the Google platform, the mapping platform, can power your own internal geospatial application. So a lot of you are probably familiar with maps.google.com and our consumer offerings. You may be less familiar with how you can take that same platform, that same technology stack, incorporate it into your own architecture to power your own custom applications. So I want to show you some examples of that, some proofs of concepts, just to maybe give you some ideas of how you can start leveraging some of the Google platform in your own internal applications as well. Jen mentioned to you Google Maps Engine and the Google Maps APIs. So those are really the core offerings that we offer to developers and organizations. So the Google Maps API, as Jen mentioned, is being used on over 1 million websites today. It's not only the most widely used mapping API, it's the most widely used API of any kind on the internet. In fact, more traffic comes to Google Maps through through third-party websites using our mapping APIs than from actual maps.google.com. So that's how much viewership of Google Maps are being seen on other websites. Where I see the strength of the Maps platform is really in two areas. One is scalability to handle unpredicted loads on your application, and also our data sources. So, Google really gets our data sources from three different areas. One is third-party data providers and our partnerships. So, for example, we have a partnership with GeoEye and Digital Globe to source satellite imagery onto our maps. Secondly, we collect a lot of our own data. So you're familiar, you've probably seen the Google Street View vehicles going out there collecting street side imagery and collecting a lot of information about that imagery. And thirdly, it's crowdsourced data. So we have tools like Google Map Maker, which anyone here can go and access and make modifications to a map. So there are villages in third world countries that have never been mapped before that they throw mapping parties. Everyone gets together, they go out and map their village together. And that's where we get a lot of data that ordinarily you would never have. Okay, so I'm just going to show you some applications. These are just examples of what you could do with Google Maps in your organization. This first one here is a police demonstration. This application is showing what you could do with police data. If you have crime data, warrant data, in your organization. So the first thing you can do is type in an address. This is using the autocomplete service and geocoding to locate that address. It turns out just something simple like that autocomplete that you're probably used to seeing on Google, where you start typing and it guesses your search query. There is a lot of architecture going behind just that simple drop-down box, right? Because if you're typing in an address, there's billions of addresses, hundreds of millions of points of interest information that it's going through very quickly to give you that instant response. So in this case, I've typed in an address and I've located the address on the map. I could then search for nearby. In this case, I'm looking for probation violations, outstanding warrants, expired driver's licenses, and I can hit search. All this data is stored in Google's cloud, in Google's Maps engine. Like Manoj mentioned, we also have on-premise, on-site solutions as well, so you could integrate maps with an on-premise database. It doesn't have to be stored in the cloud, but there are certainly scalability advantages from having your data in the cloud. So in this case, I've brought in some of these open warrants and so forth onto the map, and I can click on any one of these to get additional information. I can use our directions API to route a police vehicle to the nearest to this address, find the shortest route. I can bring in some information about this driver's license violation here, and I can bring in Street View with just a click of the mouse. I can instantly get a Street View of that address. So this is really giving the officer some situational awareness about the scene before they roll up, right? So they can scope out the neighborhood beforehand. So the next application I'm going to show you is a public health demonstration. So in this case, this is an example of how Google Maps could be used to manage a public health crisis, such as a disease outbreak in a city. So what this demonstration does is really helps a city manage the vaccine points of dispensary and where you want to set up your vaccination spots, or where you want to set up those points where they can line up, get their flu vaccine or whatever type of outbreak we're dealing with, as well as doing some analytics on where the outbreak incidents are taking place. So in this case, I could type an address. Again, it uses the autocomplete to guess the rest of my address, and I can do a 5-mile radius search and bring in that information. So what I'm showing here on the map, the little male and female icons are outbreak incidents, male or female outbreak incidents. I can click on one, I can get the street view imagery as well. And the blue, yellow, and red icons are representing the vaccine points of dispensary. So this is where we're dispensing vaccines. I can click on one to get some information about it, such as the remaining inventory of vaccines at this location, how many people are waiting in line. So in this case, it's marked as red, meaning there's a low supply of vaccine. So what you could have conceivably are field workers out in the field taking reports in real time on their mobile device, on their tablet, on their iPhone, updating these reports, updating this information back to this map, so you can have a central dispatcher, a central crisis management team monitoring this crisis in real time and managing the redistribution of these vaccines. Maybe this one needs to resupply, maybe we need to redirect people to another location. All this data is hosted in Maps Engine as well for that cloud scalability. You can bring in other layers of information, such as if you want to bring a layer showing hospitals, if you want to bring in some real-time ambulance tracks, for example. Here's one right here. So you can bring in, we offer storage of GPS tracks. If you're doing real-time tracking of vehicles, you can bring in that to do visualization as well on a map. In addition to this real-time management of a crisis, you can also use it for doing some analysis. If you want to view heat maps of your data, where are the vaccine locations in relation to the outbreak locations, for example? Or if you wanted to do some analysis as far as show me where all the outbreak cases are where there's no vaccine location within 1.5 miles, right? This indicates there's an underserviced area here. We have outbreaks where there's no nearby locations for a vaccine. So this can be very powerful visualization in helping to manage this crisis, as well as merging it with other sources of data like demographics. So if you want to look at population densities, for example, in relation to where these outbreaks are taking place, where your vaccine locations are, to make some pretty important decisions. Okay, so this next piece I'm going to show you is something called Google Maps Coordinate. This is actually an out-of-the-box solution you can get up and running with without any development, any sort of programming, to help manage your mobile workforce. What it is a mobile application that can run on your iOS device or on your Android device. And I can show you that here as well. This will allow you to see where your mobile workers are in the field, track them in real time, and dispatch them to job locations. So you can assign them jobs and track them as they arrive at the job site and complete the jobs and report back in. So in this case, I'm showing a dispatcher view here on the map. You can see where I am here, showing up on the map. Yeah, that's about right. I can also bring in satellite view or 45-degree aerial imagery of the site. On the left-hand panel here, I see all of my workers who are running the mobile application. And what I can do is I can create a job and assign it to one of these workers. So I can create a new job. I can say investigate outbreak incident, if we tie it into the last demonstration. Type in an address. Again, uses autocomplete here. That's mine as well. That's my house, actually. And I can now bring up the list of field workers, and I can see who's the closest field worker to this address. So there's 3 of us here in the building, so there's 3 of us that are about equal distance. So I can assign it to a worker. I can schedule it to a particular time. Or I can say immediately, I can add extra pieces of information, and I can create the job and add it into the system. So I just received an alert on my mobile device. So this is the application now running on my Android phone. I can see where all my team is. I can zoom into my current location on the map. Here I am. And I can take a look at the jobs that have been assigned to me. So I've been assigned a job. I can accept the job. And I can navigate myself to the location using Google Navigation. Once I arrive at the job site, I can check into the job to say that I've arrived. And again, once I complete my job, I can hit complete. I can hit checkout. You can have some pieces of information that are required to fill out the form here. I'll just say report complete and hit checkout. And then back on the dispatch review, the job has been updated to show that I've completed the job. So this is a really easy way, kind of out of the box, using technologies that people know, Google Maps, mobile applications, to track your field workers and manage a crisis in real time. And the other thing you can do is bring in the same layers of information that we had from the previous demo and overlay it onto the same map. So, one of the things that we do when we develop our mapping applications is keep integration in mind, compatibility between all of our services. All of that data that I have stored in Maps Engine, I can bring those same data layers on the map. So the vaccine locations, the outbreak incidents, I can view all that data in one place. So while I'm managing my mobile workforce, I can also view that data on a map. So another application that we talked a little bit about is the ability to store your GPS locations in the cloud. So if you think about, if you have a mobile workforce of 1,000 or 2,000 assets or more, and they're sending GPS updates every 5 seconds, 10 seconds, that's a lot of data, right? Just in a week or a month, you could be talking about millions of data points. So it requires a lot of infrastructure to be built up to be able to manage that sort of data. And it's the type of infrastructure that Google is good at. So we provide a service that allows you to store all that GPS information in Google's cloud. Now, once it's there, you're able to do a lot of interesting stuff with it, right? So with the power of the cloud behind you, you can harvest that information to do reports and analytics, like reverse geocoding, figuring out all of these points that my workers are at, what addresses were they near? What places of businesses were they near? So in this case, this is an example of a snowplow tracker application where you could bring in various types of data, like take a look at snow cover in the city. Take a look at where all the garages may be, bring in Google's live traffic, real-time traffic layers, and also viewing now the locations of those snowplows in real time. So here's just a few examples. So all of these are tracks being served up from Google's cloud. And since all that data is there for all time, you don't have to worry about ever running out of space. You can run historical reports. So if I wanted to run a report from 2 years ago and do some analytics on where these vehicles were, it's easy for me just with a click of a mouse to bring up a report. I can generate reports like total distance traveled, the average speed of these vehicles, fuel cost to help optimize and manage your fleet. And also, like I said, reverse geocode the locations where they were, get the street address, get a street view image, and so forth. So a lot of power there. So the last thing I'll show you today is what Maps Engine looks like. So this is the platform that we've talked about today that powers all of these applications. When you get started with Maps Engine, you basically log on to this portal. I just want to show you how easy it is to use and create your own mapping applications. So in this case, these are all of the maps that I have access to. This is all completely private, completely access controlled. All of your data in here is available only to you and the people that you give access to. But essentially, if I have a map in here, I can preview that map with a click of a mouse and add various mapping layers. And to add a mapping layer of data is as easy as clicking this upload button, upload source files, and I can choose to upload my own imagery, my own vector data like ESRI shapefiles, CSV files, a variety of different formats, KML. and I can style one of these layers. So I can apply styling rules to what color to show these various polygons depending on the data underneath. And then I can just publish the data out with a click of a mouse. I get a link here to view it in Google Earth or in Google Maps. And I can just send this link out to people in my organization. If they have access, they can view the map. Or if I want to do a little bit of my own custom application building, I can bring all the same data into my own custom application. All right, and that's Google Maps Engine. Thank you.
So we're going to get started with our last presentation, which is around future capabilities. It's really about, our focus has been about in the field, offline capabilities. So via Hangout, which is Google's technology, we've got Sean Maday from California, who is the product manager for Portable. He's going to show you the capabilities of what we have today and discuss some of the things we're working on. So, are we good?
All right, so thank you all for your time and attention today. I am joining you remotely from Mountain View, California. I just wanted to start with this screen to show you that when Jennifer and my colleague David Makovsky said, "Do you want to come to New York City in February?" I said, absolutely not. And this is what I envisioned, was 44 degrees and high humidity. But I want to tell you, today in Mountain View, California, I actually only gained 2 degrees by not coming out to see you in person. So take my foreshadowing and foretelling for what it's worth. So today I wanted to talk to you a little bit. Oh, that's too far forward. Today I want to talk to you a little bit about what my team is working on here, specifically what we're doing around a capability we call Portable. Portable is the recognition that while we can do lots of interesting stuff in the cloud, quote unquote, there are many situations where connectivity to the internet just isn't a possibility. So I think my colleague David McCluskey mentioned to you briefly about some things we're doing with Google Maps Engine. You know, we at Google have been in this mapping and kind of 3D visualization business only for about 8 years. But in that time, we have developed some tremendous tools that allow us to present depictions of the Earth to a wide consumer audience. So 1 billion downloads of Google Earth, 1 million hours of usage a day on Google Maps. And what's really interesting about all that usage is that all those users are always one click away from going somewhere else. So we have to make sure that we're constantly reinvigorating the platform with fresh imagery, terrain, and vector data that will make the platform relevant to our users. Well, in the process, we've got really good at taking lots of disparate data and making it instantly available across laptops, desktops, smartphones, and tablets. And so what we've done with Google Maps Engine is we've productized some of the same infrastructure we use internally at Google and allowed organizations and individuals to start to publish their geodata out in new and interesting ways. So what you're seeing here is just kind of a typical Google Maps Engine map. This is taking a bunch of municipal data and visualizing it on top of a Google map, but all this is being served dynamically from Google's cloud infrastructure. And our cloud infrastructure, and cloud has really become a buzzword in many ways, but our cloud infrastructure is very different and very unique. We use distributed computing to run massive parallel scale computing. That is to say that anytime you're loading a Google Map tile or a scene in Google Earth, we're using tens of thousands, if not hundreds of thousands of processors on the back end to make that imagery, terrain, and vector data quickly discoverable for you. And we actually set internal metrics on ourselves that each of those map tiles have to be served within 10 milliseconds of the time the request comes to us. So that's regardless of how much RAM, CPU, or storage it might take. We want to service that request and turn it back around in 10 milliseconds. The challenge, as you all know, though, is that there are certainly situations and instances where individuals are inhibited in their ability to get to the internet, or they're not able to get to the internet at all. And so that's why about 2 years ago we started working on what we've affectionately called Portable. Portable allows you to take a Google Earth or Google Maps experience with you into an area where you may have limited or no connectivity. So the way this workflow kind of exists is you actually just draw a polygon over the Google Earth or Google Maps scene that you want to take with you. All of that imagery, terrain, and vector data inside the polygon is mashed into a single cache file, or what we call a cut, or a portable globe. That portable globe then can be downloaded and moved to your mobile device, moved to your laptop, or and I'll talk you through some other instances where it can also be kind of served and broadcast locally. But then this same cache of data can serve up one user or up to 10 users. So we've got some really interesting use cases and some really interesting possibilities for both where this technology is today and where we're going with it in the future. So as I mentioned to you, for about 2 years, we've been iterating and prototyping on this. Today, on the left side of the screen, you'll see what we're really good at. That is to say, we're really good at taking this data and making it available on laptops and enterprise class servers. So for instance, the FBI out here in San Francisco has a tactical command post or a tactical operations center that they use to respond to disaster relief scenarios and also to barricaded gunmen and hostage type scenarios. And so what we've done with them is we've actually taken a several county area, cut that imagery, terrain, and vector data out of Google Earth, and given that to them that they can put on a server and serve locally from this tactical operations center. It gives them a full Google Earth or Google Maps experience. The software looks and feels like Google Maps and Google Earth, but they aren't using their connectivity to reach back into Google's infrastructure or to reach back across the internet. We've also used this successfully with lots of different laptop users. So back in March of 2011, after the earthquake and the subsequent tsunami in Sendai, Japan, search and rescue teams from Virginia and Los Angeles were quick to respond. And for that response, they had a long flight from the west coast of the U.S. all the way over to Japan. And these teams weren't overly familiar with the geography of Japan or the kind of the terrain landscape. So what we were able to do was again just draw a polygon over the east coast of Japan, extract all that imagery, terrain, and vector data, and then let them serve that up locally from laptops so they could make use of the 12-hour flight from Los Angeles over to Tokyo as a time to begin their familiarity with the geography on the ground. So where we're postured today and where we're headed this year, in the next quarter, in the next 2 quarters, is to move a lot of this functionality and capability into tablets and smartphones. So in just another month here, we're going to be ready to release this to some trusted testers, but this is the ability to take that same cache file with you and run it on an iOS or Android device, on a tablet or a smartphone. So again, you have all of that mapping content, all of those vector tiles, all of that imagery with you resident on your device, and you're not relying on network connectivity to stream that data in. So today for the enterprise class server and then the laptop versions, we have builds for Mac, Linux, and Windows. And as I mentioned to you, the 2 mobile platforms that we're targeting are iOS and Android for some upcoming releases there. So what this starts to do is it starts to give you some flexibility in how you deliver your geospatial data to your end users. Consumers in general have become very comfortable navigating on a Google map and asking location-based questions, for instance, how to find the nearest Starbucks using Google's mapping platforms. What we want to do is we want to extend that consumer familiarity into enterprise scenarios, specifically into disaster response and kind of field data collection scenarios. And so to do that, we have a couple different solutions we're architecting. One is we envision the ability to cut out a portion of Google's base map tiles and take those with you into the field. In addition to that, though, there's lots of interesting points, lines, and polygons that organizations and municipalities have in their GIS repositories that aren't necessarily something Google's going to publish or may not be something that organization wants to release to the public. In that case, those points, lines, and polygons can be uploaded into Google Maps engine. They can be processed, styled, and stored, and then all of that vector data or imagery data can be pulled down as a part of this offline portable cut. In addition, one step beyond that is we have also some customers out there and some partners out there who use a product we call Google Earth Enterprise. Google Earth Enterprise, if you've ever heard of Virtual Alabama or Louisiana's Virtual Virtual Louisiana project. These are instances that actually recreate a Google Earth or Google Maps experience all behind the firewall. And in that case, those organizations also have their own Google Earth Enterprise tiles. What we envision is a true hybrid solution where tiles from Google's base map, tiles from Google Maps Engine, and tiles from Google Earth Enterprise can all live together in a single cache that can be then pushed from tablets to smartphones, back to command posts, and give comprehensive geospatial experiences in those situations where the network can't be relied on. In addition to that, we're also working on a few possibilities of putting out WMS from these from this portable software. So that is to say, we want to try to support open geospatial standards, and we want to try to be supportive of the formats that the Open Geospatial Consortium has decided on. So what we envision is one single portable repository that can fuel both a Google Earth, a Google Maps environment, but also feed imagery, terrain, and vector data back into your legacy GIS visualization suites. So as we move forward with this, I'll just show you a couple more slides before I jump into a couple demos. We envisioned the ability, or we're working hard on the ability to cut one of these portable caches directly out of Google Maps Engine. So if you already have your data in Google Maps Engine, if your users are already using Google Maps Engine to interact with your geospatial data, it'll be as simple as drawing a polygon, drawing a bounding box across the area of extent you're interested in cutting, deciding how deep into that area you want to cut. Do you want this to be kind of a surface level cut, or do you want to go all the way down to zoom level 18, 19, 20 to get some real high resolution data? You'll kick off the cut, and using Google's massive parallel computing infrastructure, we will cut that imagery for you and make it available for you to download. There's also some really interesting possibilities, though, that I want to kind of get you thinking about. And again, my goal today is just to throw out a bunch of ideas at you and get you thinking about the art of the possible. But one thing we've been playing with is ways that that you could extend this functionality programmatically. So we at Google are big fans of application programming interfaces, or APIs. That is to say, we publish Gmail, 500 million Gmail users, but we also like to publish an application programming interface. So some motivated, dedicated developer out there can create their own front end for Gmail, and they can release it as their own app. And that same kind of philosophy extends into all of our mapping products. So the Google Maps API, which has been installed and implemented on almost 1 million different websites out there on the open internet, is another example of this. And so we plan to extend the functionality of Portable into this same programmatic landscape. So what you're seeing here is the National Weather Service, their regular weather warning map. And it's a very useful map to just get a quick kind of situational view at where in the country counties are being affected by flooding, snowstorms, severe thunderstorms, you name it. But what's really interesting about this is that the National Weather Service pushes all of this data out via XML alert feeds. And so this XML is very interesting. It's updated in near real time, constantly from the National Weather Service. So what we played with last week, and what I'll show you a couple other examples of where we've used this, is we've actually programmatically set up different alerts and thresholds so that we can actually monitor these alerts in real time and kick off a cut of our portable content based on the severity of alert and based on what specific counties might fall in that alert zone. So we go from parsing this XML with it, which any of you can do certainly. It's an open feed, but to generating a KML polygon, and that KML polygon is what feeds our portable cutter. So for instance, this was last week. There was winter storm warning for the panhandle of Texas on into Oklahoma. And what we actually did was we were cutting off cuts to make our base map tiles available in those areas for first responders who may have needed that situational awareness but couldn't guarantee that the cell phone network would withstand the effects of some winter weather down there in Texas. Another place we've used this, and kind of most notably and recently, is with the National Oceanographic and Atmospheric Administration's cone of uncertainty that they release around hurricane paths. So this was the projected path for Hurricane Sandy, released on the Sunday before the storm. we were again able to programmatically go out, grab these cones of uncertainty every 2 hours, convert the cone of uncertainty to a polygon because they were releasing them as shape files, and then from that polygon, in real time, cut map data so that we had an offline cache or an offline repository of this map data that we could then push out to emergency operations centers or push out to command posts where first responders could make use of it. So at this point, we're kind of in a, we follow the crawl, walk, run phase of development. We're very much kind of past the crawling phase here. We're ready to start walking and start pushing some of this content out to a broader audience. And so again, my goal to you today is just to get you thinking about how this capability could be used for your constituents, for your stakeholders, to make their workflows easier, more conducive. So what I want to show you now is actually what Portable looks like. So bear with me. I think we got a little bit of lag on the screen sharing here. All right. So what this starts to look like is Portable is just a desktop application. So I'm using a Mac today, but I could certainly be using a Windows device, or I could be using a Linux device. And what you're going to see here is I just kicked off that Portable server. The Portable server then, and I could go completely offline, but then I would lose my connection to you guys. So you'll have to take my word for it, and maybe my colleague David Makovsky can show you some of this offline. But truly, the map tiles I'm showing to you right now are being served from my local hard drive as opposed to from Google's infrastructure. So what you're seeing is a Google Earth experience, 3D Google Earth, and this was an area that I cut just around Fisherman's Wharf here in San Francisco. And here you can really see where we go from that high-resolution imagery to the much lower resolution imagery, all based on where I drew that bounding box and where I made this cut. And this will really highlight the granularity of this tool, that you can cut something as small as a neighborhood, or you can cut an area as large as a state, a province, or even a countrywide kind of view with very high-resolution imagery, terrain, and vector data. All of these cuts come across as a single file format. So now I can peruse the portable globes or portable maps that I have native on my machine. And the one I want to show you here is kind of an interesting one we did for a group in Spain. This one is unique because it's actually loading Google's map tiles right alongside of some tiles cut from Google Maps Engine. So as I zoom in here, and again, all of this is coming from my local machine, not being broadcast across the network or across the internet. I have the ability to visualize Google's high-resolution base map tiles, to see where the roads intersect, and then I can start to turn on some of those proprietary Google Maps Engine layers that may have been cut. So maybe these are layers that the organization didn't want to make public. For instance, these are some of their natural gas pipelines, some of their natural gas valves, and all that data can live right alongside each other offline, and it's made available for users that are kind of designated within my access control. So myself as a Google Maps Engine administrator, I can decide who I want to be able to cut this data, how much data I want them to be able to cut, and I can start to wrap access controls around it so that as we support ad hoc partnerships, like we often find in the aftermath of a critical incident, we can facilitate dynamic information sharing without necessarily giving up all the source data that may be resident inside of our organization. So lots of neat possibilities here. I want to show you one other feature here, and that is the ability to broadcast. So for myself as a laptop user, if I was in a small tactical operations center or it was shift change, perhaps, and I wanted to collaborate with those around me, what I can do is actually kick off a broadcast session. This would allow me to share the cache that's on my local machine with anyone else on my local network. So whether we're all plugged into the same server, or maybe we all joined up on the same wireless network here, this is a way that we could share this map data and create a true situational awareness, common operating picture across a small team or a small network of responders. So that's what I wanted to show you today. Again, the product is called Portable. We envision this as a way to extend the functionality and the consumer familiarity of Google Earth and Google Maps into situations where we can't rely on outside connectivity. I'll tell you today, Google Earth Portable, or the Portable product, is used in the International Space Station, And you don't get much more bandwidth disenfranchised than you do when you're orbiting Earth a couple hundred miles above the equator. One other example here, I'll just show you how this works in conjunction with the Google Earth desktop client. So for instance, I can go back to serving up my 3D San Francisco map. I can then launch the Google Earth Enterprise client from my desktop, and I get that full Google Earth user experience, all the same buttons and functionality, but running completely locally on that cache of map data that I have resident on my local machine. So again, this is a way you can quickly harness the familiarity of Google Earth and Google Maps, but populate it with the imagery trained and vector data that's relevant to your stakeholders. That's all I wanted to show. I'm confident that during the question and answer session, my colleagues there in New York can answer any questions you might have. And if any of this looks interesting to you or looks appealing, we're always looking for trusted testers and partners who can help us take this capability in the field, give us some feedback, and help us make this a better, more responsive product that's relevant to what you do. Thanks for your time today, and have a great afternoon.
Thank you, Sean. Really appreciate you doing that.